Okay, a video here for the 4F notes on factoring. If we're going to factor any number, we have to find every number that multiplies into the number that we're trying to factor. Okay, we're trying to find the multiples. Okay, the multiples of all the numbers that we're trying to factor in. Okay, so just hypothetically, let's say we have the number 30, right? We got to find out all the numbers that multiply into 30. Well, okay, so 30, we really know that 30, we could call it 5 times 6, we call it 10 times 3, 15 times 2. Doesn't really matter. But let's say, the number 30, for instance, we could factor it into, 15 and 2, because 15 times 2 is 30. Okay. Now, we can't break the 2 down anymore. Okay. 2 is a prime number. However, 15 is not a prime number. Okay. Because 15 can factor into 3 times 5. Okay. We can't divide 3 anymore. We can't divide 5 anymore. So if we were to take, 30, what it would really factor into is 3 times 5 times 2. 3 times 5 times 2. Those are the factors of 30. Okay, those are the numbers that multiply into 30. Okay, so when we're doing it with polynomials, it's kind of the same deal. We're trying to simplify it down into all the prime numbers that it factors into. Okay, so if we have a polynomial expression, in order to factor it completely, we have to write it as a product of non-factorable which are prime numbers, okay, prime polynomials, with coefficients that are integers, okay, which are positive and negative whole numbers, okay. So that's kind of what we're doing here. I'm going to give you an example here, and I'm going to create another example too. So here we have a polynomial where we have a common monomial factor. These are kind of the easiest to do. These are kind of the simplest ones, okay. So we have 8x squared plus 20x. We want to factor it into something, okay. Well, first of all, we're going to find out what multiplies into both terms, okay. So we have 8x squared plus 20x, okay. Now, looking at what multiplies into 8, it's 2 times 4, okay. 20 is 5 times 4. So what we see here is that the number 4 multiplies into 8x squared, and the number 4 also multiplies into 20. So what we can do is we could pull out a 4. Okay, so what we can pull out here is a 4. Whoops. Now, if we divide a 4 out of there, let's look at what we're left with. Okay, we're left with 2x squared plus 5x. Okay, can't pull anything else out of here, out of the 2x squared. Can't pull anything else out of the 5x in terms of numbers. Okay, because we can't divide anything else that commonly goes into 2 and 5. However, both of these terms also have an x. Okay, we have an x squared here and an x there. So what we can also do is we could also divide out an x. Okay, so we can pull an x to the outside. So if we pull out an x, what we're left with here on the inside is, so we have 2x squared, we took an x out, so we have 2x there. 5x, we took an x out, so we're left with 5. And this would be that monomial totally factored out. Okay, 4x times parentheses 2x plus 5. Okay, so you're just undistributing basically into the simplest way we can. We're just taking it back and putting it back as to where it would look like if we were not distributing it. Okay, kind of the opposite of what we did on the 4D notes. Okay, so the 4D notes, we had something like this, and we multiplied, distributed, combined like terms, and we got something like this. Okay, this is just the opposite. We're taking this and we're simplifying it down into the terms that multiply into it. Okay, so I'm going to draw up another example here real quick. Pause the video if you need to, and I'm going to write up another example right to the right of this thing here. So let's say we have 8x squared y plus 12xy minus, let's say, 16y or something like that. Okay. And we wanted to factor this thing out. Well, first we can look at the numbers. Okay. So do we have any common numbers that multiply into 8, 12, and 16? Okay. Well, if we look here, and if you want to factor these numbers out, we can, but I don't think it's really necessary. I think we can kind of guess and check. So the number 2 multiplies into 8, 12, and 16. They're all even numbers. Okay. But there's a higher number that also multiplies into them, 4, because 4 multiplies into 8, 4 multiplies into 12, 4 multiplies into 16. Okay, so we could pull a 4 out. So if we pull out a 4, okay, we divide the 4 out of here, so we have 2x squared y plus, taking the 4 out of the 12, so we have 3xy there. And then minus 16y, we take the 4 out, so we got minus 4y there. Now, is there anything else in here that's common to all three things that we can divide out? Well, all three of these terms have a y. We have a y, a y, and a y. So we could pull a y out. So we could pull a y out, attach it to the 4. And now look at what we have. We have 2x squared, the y is gone, plus 3x minus 4. Now, once we do this, we could try to factor this stuff out. That's probably going to come on a later note sheet for right now. But for now, we can't do anything more with the 2x squared plus 3x minus 4. We'll look at that a little bit more when we get into the next set of notes, where if we have a quadratic thing right here, we may be able to factor it further. But right now, this is kind of the gist of these notes here, okay? Factoring these polynomials. So you can kind of use these two examples that we did to try to do these 10 problems right there, these 12 problems here, excuse me. And that's that. I'm going to go to the next part of the video here, where we have some other things. So I gave you guys a few of these on the 4D notes. So recall, if from 4D, if we have a plus b times a minus b, that really gave us a squared minus b squared. Meaning if we have a difference of two square numbers a and b, okay, which is really a squared minus b squared, we could factor it into a plus b times a minus b. So hypothetically speaking here, let's look at an example. Let's say we have let's say we have 4x squared minus 36 or something like that. Okay. Well, we should notice that 4x squared is a square and 36 is a square. Okay. Because if we took 4x squared and we square rooted it, it would be 2x. And if we took 36 and square rooted it, it would be 6. Okay. So because those two numbers are squares, we could take the square roots and then just add them and subtract them. So 4x squared minus 36 really becomes 2x plus 6 times 2x minus 6. And that's that. Okay, so we use a difference of square rule for that, and then we have these problems here that we can kind of do to work with that. Okay. Now, one thing I also want to look at here is I want to look at a couple of these example problems down here on the bottom, because we may need to do some factoring before we get a difference of squares. So we're going to have some difference of squares here. These four are pretty standard. But let's just look at number 23, for example, right here. So 23, we have 125 m to the fourth minus 20 n to the fourth. So right here, we're looking at this thing, face value right here, and we're saying, well, wait a minute. 125 is not a square number. 20 is not a square number. Okay? But we can still do that. We can still do this because we can factor out some numbers from 125 m to the fourth and 20 n to the fourth. Okay? Sort of like we did on this first step right here. So looking at this thing here, so we have 125 n to the fourth minus 20 n to the fourth. Okay? Well, there are some numbers that multiply into 125 and negative 20. All right? Now, 125, we want to factor out 125. Okay, 125 is going to be just 25 times 5. And 25 is just 5 times 5. Right, so 125 is 5 times 5 times 5. Okay, and then if we have negative 20, or just 20, we know 20 is going to be 5 times 4. Okay, so 125 and 20 both have a common factor of 5. So we can divide a 5 out of this thing. So if we pull a 5 out of this thing, 125 divided by 5 is 25. So we have 25 m to the fourth. Negative 20 divided by 5, we have negative 4 n to the fourth. Okay. Now, in this thing here, now we have a difference of squares. We have 25 and 4. Okay. 25 m to the fourth and 4 n to the fourth. Okay. So if we were to take the square roots, so if we have 25 m to the fourth and we root it, well, the root of 25 is 5. The root of m to the fourth is m squared, right? If we have 4n to the fourth, we root it. Square root of 4 is 2. Square root of n to the fourth is n squared. Okay? So now what we have is we have a difference of squares of 5m squared minus 2n squared. And we have 5m squared plus 2n squared. And so that is totally factored out. We basically took, we pulled the 5 out of here first. We pulled out the 5 from here, right? And then we were left with this, 25m to the fourth minus 4n to the fourth. That's a difference of squares. So you square root the 25m to the fourth and the 4n to the fourth, and you get 5m squared and 2n squared. And so now we're just taking the difference of those two squares there. And now that thing's totally factored out. That's number 23 kind of done for you guys right there. Again, numbers 1 through 4 up here are just going to be a difference of squares. Should be pretty simple. These ones we're going to have to factor out some terms, some numbers here first. And then what's left in the parentheses there, we could probably work some difference of squares problems there. All right. Next, if we have two cube numbers being subtracted from each other. Okay, and we did this difference of cubes thing a little bit in the 4D notes as well. So if we have the difference of cubes, a cubed minus b cubed, what this factors into is a minus b times a squared plus ab plus b squared. So, a quick example here. So let's say we have something like, let's say we have 27x cubed minus 64, something like that. When we know 27 is really 3 cubed, okay? So 27 is 3 cubed, all right? So what we have here is 27x cubed is really 3 cubed x cubed, which really we can reduce down to 3x to the third power. And we know 64 is really 4 cubed. Okay? So we have 3x to the third power minus 4 to the third power. So we're going to use 3x and 4 as our a and our b. All right? So what it'll factor into, if we go back to this formula here, a minus b, so we're going to have 3x minus 4 times 3x squared. So 3x squared is really going to be 9x squared because 3 times 3 is 9. Okay. Plus AB. Okay. So 3x times 4 is 12x. So plus 12x. And then 4 squared is 16. So we'll have this here 3x minus 4 times 9x squared plus 12x plus 16 just by rewriting this thing as an actual cube. As an actual cube. If we have a sum of cubes, all right, so a cubed plus b cubed. What this factors into is a plus b times a squared minus ab plus b squared. So if I do an example of that, so let's take something simpler. Let's say we have 8x cubed plus y cubed or something like that. Okay. Well, we know 8 is really 2 cubed. Okay. So 8 is 2 cubed. So 8x cubed really becomes 2 cubed x cubed. And 2 cubed x cubed really just becomes 2x cubed. And we're adding y cubed to that. Okay. So our a term is 2x, our b term is y. So on the outside here, we'll have 2x plus y for our a plus b. And we'll times it. Okay, so we have a squared, so 2x squared, which is 4x squared, minus ab, so it'll be minus 2xy, plus b squared, so it'll be plus y squared. And there we go. Difference of cubes, or sum of cubes, excuse me. And so now you can go down to the bottom here and do these problems out using the either sum of cubes or difference of cubes thing there. And we can knock these problems out. Again, if we don't have a cube number, then we may need to do some factoring before we end up kind of doing that. Okay. So that's what we have here. you have any questions while you're going about this, please let me know. Use these two rules as a guide. I think all the ones down here below this are going to be either sum of cubes or difference of cubes. Okay, so we just got to find out what numbers we got to use for our a and b, and then just plug it into our formula. All right, that's what we got. Thank you guys. Have a good day, and I'll be around if you need me.